The scientist's nightmare, the agony of powerless forecasting. Inside the high-security monitoring rooms of the Volcano Observatory, the air is thick with caffeine and desperation. Dozens of monitors flicker with red lines and heat maps, but the most important question remains unanswered. A lead geologist stares at a screen displaying a massive spike in seismic activity. They know the magma's moving. They know the pressure is reaching a critical threshold. They can see the disaster coming from months away, but they cannot say if the ground will vanish in the next 10 minutes or the next 10 days. This is the ultimate nightmare of modern science, the ability to watch a catastrophe unfold without the precision to tell the world exactly when to run. For decades, humanity has operated under the illusion that technology grants us mastery over nature. We have mapped the human genome and landed rovers on Mars, yet the 3 miles of rock beneath Yellowstone National Park remain a dark territory. The limitation lies in the sheer complexity of fluid dynamics and crustal mechanics. Magma is not just liquid rock. It is a chaotic mixture of molten minerals, dissolved gases, and solid crystals. Predicting its behavior is like trying to predict the exact path of a single drop of water in a boiling pot. The physics are non-linear, meaning a small change in pressure can lead to an instantaneous and massive explosion, or it can simply fizzle out into a minor tremor. The United States Geological Survey employs the most advanced sensors on the planet. GPS stations can detect the ground rising by a fraction of a millimeter. Satellite radar can map the bulging of the Earth from space. Borehole strain meters can feel the tectonic plates grinding against each other with incredible sensitivity. However, these tools only tell us what is happening right now. They do not provide a clear window into the future. The data tells a story of unrest, but it does not provide a countdown. To a scientist, the difference between a week and a month is a lifetime when it involves the evacuation of millions of people. One of the greatest hurdles is the problem of false alarms. Geological history is full of examples where volcanoes showed every sign of an imminent eruption only to go quiet for another century. If scientists call for a massive evacuation and nothing happens, the economic and social cost is astronomical, and public trust is shattered. But if they wait for the perfect data, the window for escape might close forever. This creates a paralyzing psychological pressure on the experts. They are forced to gamble with human lives using data that is fundamentally incomplete. The subterranean world of Yellowstone is a labyrinth of interconnected chambers and conduits. When magma moves, it fractures the surrounding rock, creating the seismic swarms we observe. But we cannot see the thickness of the walls between these chambers. We cannot measure the exact gas concentration inside a magma pocket without being inside it. We are essentially trying to diagnose a patient while looking through a frosted window from a mile away. The signals we receive are echoes and shadows of the true violence occurring deep underground. The nightmare deepens when we consider the speed of geological failure. While the buildup to a supervolcanic eruption takes thousands of years, the final transition from stability to explosion can happen in a geological heartbeat. A sudden collapse of a rock ceiling within the magma chamber can trigger a chain reaction that moves faster than any communication network. By the time the sensors register the definitive signature of a terminal blast, the shock wave is already traveling through the crust. The technology is fast, but the physics of a collapsing caldera are faster. In the final stages of unrest, the sheer volume of data actually becomes a liability. During a crisis, sensors begin to fail due to extreme heat or massive tremors. The incoming stream of information becomes a chaotic noise of error messages and off-the-scale readings. Supercomputers designed to model the eruption struggle to process the rapid changes in real time. The experts find themselves in a situation where they have too much data to analyze, but not enough clarity to act. It is a digital fog of war, where the enemy is the very earth beneath their feet. The frustration is not just technical, it is deeply personal. These scientists spend their lives studying the park. They know every trail and every thermal pool. To watch the data turn into a death warrant for a place they love while being unable to provide a precise timeline is a heavy burden. They are the watchers on the wall, but they are holding a broken telescope. The public expects a level of certainty that the laws of physics simply do not allow. We want a digital countdown clock, but nature only provides a low and steady rumble. The conclusion that many experts are forced to reach is a humbling one. Our technology is a candle in a dark cavern. It illuminates a small circle around us, but the vast reaches of the Earth remain in shadow. We can forecast the weather, we can track an asteroid, but we cannot perfectly time the heartbeat of a supervolcano. The unpredictability of Yellowstone is a reminder of our place in the world. We are guests on a planet that operates on a scale of time and power that dwarfs our digital gadgets. In the final scene in the observatory is often one of quiet resignation. The alarms are screaming and the monitors are red, but the scientists can only look at each other and wait. The forecast is certain, but the timing is a mystery. They have done everything humanly possible to decode the signals of the giant, but the final word belongs to the Earth. As the ground begins to heave and the sensors finally go dark, the nightmare of the powerless forecast reaches its end. The time for science is over, and the time for survival begins.